Hey guys, back for some more in chapter 4, but we got to start off with jokes. You know, I was looking at this and I showed you my shirt in my last video from 2013-14, and I don't think I showed you guys the back very well. So here was the front. These are the jokes of the day. And here was the back. Ask me anything, I'm a chemist. You guys couldn't see that. So here's my one from 14-15. I got to read this close. This is the joke of the day. Don't trust atoms. Let's see, what does it say? You're my favorite person. They make up everything. I wrestled a shark once. They make up everything. My name is Adam. So, and here's the back. Let's see if you guys can see it. It says catalyst. A catalyst, and that's something that we will talk about in the spring. So if you could see that. So those are the jokes for the day, and you guys can now start thinking a little bit about our shirt. So we're just going to continue on. We were talking about oxidation reduction and oxidation reduction numbers. So here we go. Again, we're getting closer to done with chapter 4. Okay, so we went over this slide, and I gave you a few more that I want to go over with you guys just to check doing oxidation numbers. Okay, so then here is the next slide. Oxidation reduction, and there's a couple of these. I think they're called mnemonic devices. I always call them easy ways to remember things. So, actually, this topic that we're learning about now, and it depends on how far we get, but usually in a normal year, the last chapter we cover is chapter 17, which is electrochemistry. And the lessons we're doing right now, we do again in April, just to refresh our memory, and that goes with electrochemistry: oxidation, reduction, oxidation, the loss of electrons, reduction, the gain of electrons. And I review these little mnemonic devices, easy ways to remember things. So Leo the lion goes grr. What that stands for: Leo the lion goes grr. Leo, loss of electrons is oxidation. Loss of electrons is oxidation. And grr, gaining electrons, is reduction. So Leo the lion goes grr. Loss of electrons, oxidation. Gaining electrons, reduction. The oil rig, same thing. Oil rig, oxidation is loss and reduction is gain. So, and I'll review those again, but this will be important for right now. And then the way I learned it and the way it's always been are these things, and it's a little bit confusing, but the oxidizing agent is the reactant that gets to be reduced, and that causes something else to be oxidized. So the way I always have taught it is that the oxidizing agent equals being reduced. Those mean the same thing. Oxidizing agent and being reduced mean the same thing. And reducing agent is the reactant that gets to be oxidized. So reducing agent equals oxidized and causes something else to be reduced. So again, oxidizing agent and reduced really mean the same thing. And reducing agent and oxidized get to mean the same thing. And in AP, I'm going to read my notes here. They decided back 4 or 5 years ago to change their vocabulary. And instead of saying reducing agent, they called it the ability to reduce. So, and instead of oxidizing agent, they call it ability to oxidize. I have no idea why they did that, but they did. So, and I'll review that too. So this says, it says, write an equation for the combustion of methane gas. So we'll do that. And we're going to do a couple of these here and identify the oxidizing agent and the reducing agent. Which reactant is oxidized and which reaction is reduced. And the diagram over on the right kind of shows on the left is something that's oxidized. They lose electrons. Their oxidation state increases, and they are called the reducing agent. And it shows you there the size gets smaller when something's oxidized because it's losing electrons. And reduced is gaining electrons, the oxidation state decreases, and it's the oxidizing agent. So, okay, so let's go on and do a couple of these problems where we look at an equation and we figure out what has been oxidized and what has been reduced. Okay, so I'm back to my whiteboard here, still in my Mrs. Wood's office. Okay, so the first one is methane. So we have to go back and do what we were doing in the last lesson, is we got to assign oxidation numbers. So I've got CH4 plus O2 let me move this so you guys can see this. Better. Okay, I think that's better. CH4 plus O2, and remember in combustion, we get off CO2 and water. Okay, so there's the equation. Now, it's always right for us to balance this, and so if I balance, carbon's balanced, but I need a 2 there to have 2 H's, and then for O, I need a 2 there. But actually, in doing this and assigning what's been oxidized, what's been reduced, I really don't need, the coefficients don't play in at all. So the first thing I want to do here, we're figuring out what's been oxidized, what's been reduced, is assigning oxidation numbers. Well, here, I know this needs to total 0 because it has no charge. And I know hydrogen is always a positive 1. That's one of the rules. In a compound, hydrogen is positive 1. So I have positive 1 times 4 is positive 4. So I call this a fill in the blank. So then carbon would have to be a negative 4. So there's the oxidation numbers for hydrogen and carbon. Now here, you remember, okay, in a compound, oxygen or an ion, oxygen is always, it's negative 2, unless it's a peroxide. But here, go back to the first rule, whenever something is by itself, its oxidation number equals its charge. Well, this has no charge, so then O for oxygen would be 0. Okay, and then on this side, here, this needs to total 0 because it has no charge overall, and I know oxygen is a negative 2. So if I have negative 2 times 2, it's negative 4. So fill in the blank again. So then carbon here would be positive 4. Okay, and over here, I know this needs to total 0, but I know that oxygen is a negative 2, so negative 2, and I know hydrogen is a positive 1. So what I'm doing here is I'm just assigning oxidation numbers. And now I compare the left to the right, and if we've done this right, always one element's oxidation number should have went down. And so if I compare hydrogen positive 1, hydrogen didn't change. So it was neither oxidized or reduced. Oxygen was 0 and it became negative 2. So I always remember it this way. So when I like to go shopping at Walmart because Walmart they reduce their price. Well, that means they go down. So if I buy a pair of socks at Walmart, they reduce their prices, so they go down. Well, this went down from 0 to negative 2. So this was reduced, which means, like I was saying, it is the oxidizing agent. So remember, if something is reduced, that means it's the oxidizing agent. Those mean the same thing. Okay, and then here, then if I go on, carbon went from positive or negative 4 to positive 4. That's an increase. So if the number goes up, then it has been oxidized, which means it's the reducing agent. So go back and answer the problem that was there. Then oxygen was reduced, which means it's the oxidizing agent. And then carbon was oxidized, so it was reducing agent. Let me say that right. So oxygen was reduced, so it was the oxidizing agent. And carbon was oxidized, so it was reducing agent. So here, so the oxidizing agent, what was reduced, what was the oxidizing agent was oxygen. And then carbon was oxidized, which means it is the reducing agent. Okay, I want to do a couple more of these. Okay, here is another one. So here's another example. So we've got FeO makes Fe plus O2. And one thing, too, to point out here, again, this two, the 1 and the 1, when you're determining what's been oxidized and what's been reduced, the coefficients don't factor in at all. They don't factor in at all. Okay, so if I go here, again, if I go back and balance it, just being a chemistry nerd, I always balance. But again, those things don't make any difference here. So I just want to know what was reduced. Here's the question. What was reduced and what was oxidized? Okay, so what I'm going to do is I'm going to assign oxidation numbers. So I know this needs to total 0 because oxygen has no charge, or the compound has no charge. But I know oxygen is -2. And a compound, oxygen's -2 with the exceptions of a peroxide. So then fill in the blanks, so then iron had to be +2. Okay, so oxygen is -2, iron is +2. Now on this side, both of them are by themselves, and remember, whenever something is by itself, its oxidation number equals its charge. So here, iron would be 0 by itself and no charge, and oxygen would be 0. So if I compare then, oxygen went from -2 to 0. That's an increase. So then oxygen was oxidized. If the number goes up, it's been oxidized. And iron went from +2 to 0. That's going down. And again, that's my Walmart example. They reduce the prices, and so they go down. So I like that. So that means iron was reduced. So the answer to my question then, what was reduced was iron, and what was oxidized was oxygen. Okay, let me do one more of these. And again, this is something I know I did. And of course, last year had such a weird ending to the year, but it's something that I did get to, and probably your guys' teachers, depending on what teacher you had and where you were at, if you had chemistry 2 years ago, probably most of you got to this. Okay, so the board is all messy. I'd like to do one more example and then go on to the next slide here. You can see why I prefer to do these at school. It's much easier to bring expo markers from home or to home so I can do this and it's not nearly as messy as this. Or what would be great is if we went back to school full time. That would be great. We'll just see what the decision is of the powers to be on that. Okay, so let me do one more example here. So we're deciding what's been oxidized and what has been reduced. So here's our equation. So we've got aluminum plus HBr makes aluminum bromide plus H2. Now again, being a chemistry person, we're going to balance this, but again, it does not factor in at all. So I see 3 bromines, so if I put a 3 here, but then I see a 6, so I think I'm going to end up 3, 6, so that balances the H, and then I'm going to put a 2 there. Okay, and that balances it again, but in this case, that does not make any difference at all. Okay, so I assign oxidation numbers. So again, what I want to know is what has been oxidized and what has been reduced. So here, aluminum by itself is 0. Something by itself equals its charge. This needs to total 0, and I know hydrogen is a +1. And again, the 6 doesn't factor in at all, so that would mean bromine then would have to be a -1, +1 and -1, 0. Now here, hydrogen, again, by itself, even hydrogen, when it's in a compound, hydrogen is always +1, but by itself, it's whatever its charge is. Since it has no charge, it would be 0. And here, and for these, I'm just going to use their ionic charges. So if aluminum this needs to total 0, and aluminum is a +3, that's the ionic charge of aluminum. And bromine is a -1, so -1 times 3 is -3. So it ends up like that. Okay, so now I compare the left to the right, and bromine didn't change, so it was neither oxidized or reduced, but hydrogen went down. So then hydrogen going down is reduced, which again means it's the oxidizing agent. And aluminum went up, so it was oxidized. So what was oxidized was aluminum. So, and again, that is stuff I try to do, again, at the end of every year in first year chem. And you guys will have to, go back and see if you remember that. But if not, this is definitely something you need to be able to do at this point. And there are definitely problems in the book like this. Okay, now I want to start the next slide, not too much more. Okay, so we just did this slide where we were talking about, and again, remember, oil rig, oxidation is loss, reduction is gain, and Leo the lion goes grr, Leo, loss of electrons, oxidation, grr, gaining electrons is reduction. And here's one of these things I just throw at you guys from time to time, to absolutely nothing on a test, but an application, bleaching hair. Maybe I should bleach my hair. You guys will have to tell me. I'm not going to do it either way. But most home bleaching kits contain hydrogen peroxide, an excellent oxidizing agent. When applied to hair, and hydrogen peroxide, H2O2, and there's an example of where oxygen is a peroxide. So oxygen's oxidation number would be -1. Oxidizes melanin in the hair. Melanin, a dark color, no longer is dark, leaving the bleached look. Hydrogen peroxide also oxidizes the protein molecules containing SH called thiol, oxidizing them to sulfonic acid. These reactions make the hair more brittle, and I don't think it's a healthy thing to bleach your hair and to change the color of your hair a lot. I don't think it's a great example. Okay, I want to walk you through this slide. This is going to be the last, well, it's going to lead us into the last big topic, which is going to actually lead us into this redox titration lab. But balancing redox equations by the half reaction method in acidic solution. So we will walk through this example here. Okay, and so the first thing, and to be honest with you, I always get lazy on this first step, but you determine the oxidation number for each element, and you'd identify what element has been oxidized and what has been reduced. And then you write half reactions for the elements oxidized and reduced. And so typically what always happens here is the elements that are not oxygen and hydrogen are usually the elements in the half reaction, but I'll show you. Then we write out the half reactions. And again, I want to go through an example. And then we balance all the elements except H and O. And remember the old balancing, we always saved O to the end and then H second from the end. Here, they're not going to be at the end. First of all, though, we're going to balance the elements. Then we're going to go back and we're going to balance hydrogen and oxygen. And we're going to balance oxygen by adding water. And I'll show you what I mean by that. And then we're going to balance hydrogen by adding H plus to the equation. And again, this is new probably for all of you. Maybe one of you have done this before. Okay, and then this is always the place where I mess up. We add electrons to balance the charge. And then we multiply each equation so the number of electrons are equal. And again, this is where we've got to be careful, is we want to make sure that we balance the charge on both sides. And then we add the two half reactions and we cancel out common species. And again, of course, we need to do an example. So let me work through an example here and go through this problem. And what we're doing here is we're going to balance this reaction using the half reaction method. Okay, so and again, I'm going to go through and try and do it exactly right so you guys see exactly how to do this. Okay, so what I've got here is I've got MnO4, so permanganate ion, plus Fe, and Fe is positive 2. And we're going to Fe positive 3 plus Mn positive 2. So again, what I said, the first thing we want to do is we want to assign oxidation numbers. Well, I know oxygen's a negative 2, so that's negative 8. It needs a total negative 1, so Mn then would have to be a positive 7. Went through that kind of quick there, but I know oxygen has to be negative 2. In a compound, it always is. There's 4 of them, so it's negative 8. The charge is negative 1 for the whole ion, so needs a total negative 1, so then Mn would be a positive 7. Here, iron is a positive 2, and on this side, iron would be a positive 3, and Mn would be a positive 2. So what's happening here is Mn is being oxidized. So here is half reaction 1, and here is half reaction 2. And again, I'm sorry, I'll probably do some examples where I'll just immediately recognize that the elements not hydrogen and oxygen are always, the elements other than oxygen or hydrogen are almost always the elements oxidize and reduce. Okay, so the first thing after writing out the two half reactions, so manganese is being oxidized, manganese is being reduced, iron is being oxidized. Okay, so now I've done that. So the first thing that I do is I balance all the other elements other than oxygen and hydrogen. In this case, Mn is balanced and iron is balanced, so they're balanced. Okay, then I balance the oxygens with water. So this is how I do this. So I know I have 4 oxygens here, so I'm going to put 4 waters here. That gives me 4 oxygens, which balances that out. So first of all, again, half reaction. Second step, then, is I balance out the elements, all the elements other than oxygen and hydrogen. Then I balance oxygen with water. Now there's no oxygen here, so I'm not worried about that. Then I balance the hydrogen with H+. Well, there's 2 times 4, there's 8 hydrogens, so I have 8 H pluses there. Okay, so I balanced out the elements, then I balanced out oxygen, then I balanced out hydrogen, and there's no hydrogen here. Now this is where I always screw up. This is where I balance the charge. So I want to make the electrons, the charge equal on both sides. So there's 8 positives and 1 negative here. So overall there's a negative or a positive 7. 8 positives and 1 negative, positive 7. And on this side, positive 2. So to get the electrons equal, to get the charge equal, and remember electrons are negative, 5 electrons. So now I have 5 negatives and 7 positives, so I have positive 2. Now here it's positive 2 and positive 3, so I'm going to write 1 electron there. And again, that's always the step that I kind of make a mistake on, is balancing the charge. So I did the half reactions. I balanced all the elements other than O and H. Then I balanced oxygen with water. I balanced the hydrogen with H+. Then I balanced the charge with electrons. Now I'm going to get the electrons equal on both sides because I want to get rid of the electrons. So if I see 5 here and 1 here, I'm going to get 5 on this side. So I'm going to multiply this whole thing by 5. The reason for that is I want to get the electrons equal on both sides. So I'm going to distribute that all the way through here. So I'm going to have 5 electrons here, 5 irons here, and 5 here. So the 5 just distributed like that. Okay, now I'm going to, there's something common on both sides, I can cancel that out, and that should always be the electrons. Sometimes you can cancel out the H+, and sometimes you can cancel out the water, which in this case, that's not the case. So everything on the left is the 8 H pluses plus the MnO4 negative plus the F5 Fe plus 2. So I had 8 H pluses, the MnO4 negative, and the 5 Fe plus 2. Now what's on the right that I haven't canceled out is the Mn positive 2, the 4 waters, so the Mn plus 2, the 4 waters, and the 5 Fe plus 3s. And at this point, everything should be balanced. So I have 8 H's, 4 times 2, 8 H's, 1 Mn, 1 Mn, 5 irons, 5 irons, I think that's it, 4 oxygens, 4 oxygens. But the charge should be balanced too. So I have 8 positives and 1 negative, but I have 10 positives. So I have really 5 times 2, 10 positives, and 8 more make 18, and then 1. So I really have a net charge of positive 17 on this side. Here, I have positive 2, and 5 times a positive 3 is positive 17. So the charge should be equal too. So again, I had 8 positives, and then 10 more here. 5 times 2 is positive 18, and minus 1 is 17. Here, positive 2, and 5 times a positive 3 is positive 17. And that is done. So that is the balancing using the half reaction method in acidic solution. So I want to do one more thing, almost done, is I want to talk about it in a basic solution. And I want to come back and I want to do some more of these with you. To do these on a video are kind of a bit of a challenge. But the other possibility that that a problem could ask you is, what do you do if it's in a basic solution? So if it's in a basic solution, then you neutralize all the H plus and add the same number of OH to the other side of the equation, okay? So think about it. Acids have H plus, while bases have OH. And you can't read that, but you add OH to neutralize all the H plus, but you add the same number of OHs to the other side. Okay, so let me just show you here. If we did this, this is now, the way we're doing this is this right now, this is an acidic solution. This is an acidic solution. So if I do this in a basic solution, what I'm going to do is, what that said is I want to get rid of the H pluses. So I'm going to put 8 OHs here. And if I add that up, this gives me 8 waters. But if I add 8 OHs here, I've got to add 8 OHs here as well. So again, what I do when it's in a basic solution, I go through this. Typically, they'll say a basic solution. The way you normally do it is acidic solution. Now, if I write this out, so it didn't change this, it didn't change this, it didn't change this, it didn't change the 4 waters, it didn't change the 5 Fe plus 3, and it didn't change the 8 OHs. But now I have 8 waters, and you could leave it like that, and that would be fine, and this would be in a basic solution. But what typically they would do, and you can tell it's basic because it's OH. See, this was acidic because it had H plus, is a lot of people would just get rid of the water and make this 4. So the way most chemists would write this, again, just reducing it down, so then everything else is the same. Okay, and now it's in a basic solution, and we can tell that because it's got OH. Okay, that's a lot to take in, and we definitely need to do some of those in class, and we will. So I'm going to stop there, guys. We're grind time, right up to fall break. We're going to be grinding away. So hey, have a good day, and I will talk to you soon.